This video is on diluting solutions. Dilution occurs when more solvent is added to a solution, but the moles of solute remain the same. This means the ratio of solute to solvent decreases, and that means the molarity decreases. Concentration is the opposite. This is when solvent leaves the solution, usually through evaporation, but the moles of solute remain the same. The ratio of the solute to the solvent increases, and thus the molarity increases. Molarity is moles of solute divided by liters of solution, or abbreviated, M equals moles over liters. Rearranged, molarity times liters equals moles. When doing a dilution, the number of moles of solute remains constant. That means M and L must be inversely related, so if one goes up, the other must go down to keep the mole constant. So think of a solution, we'll call it condition 1. M1 times L1 equals the number of moles. In condition 2, we're keeping the number of moles steady, and the molarity of the second condition times the volume of the second condition equals the same number of moles. You may remember that if A equals B and B equals C, then A equals C. Applying that to this situation, if M1 L1 equals moles, and M2 L2 also equals moles, then M1 L1 equals M2 L2. This gives us the dilution equation. M1 V1 equals M2 V2. We're using V instead of L because if and only if V1 and V2 are in the same unit, then you do not need to convert to liters. You can use whatever unit the volume is in. First example, 250 milliliter solution of a 0.1 molar sodium chloride solution is diluted to a volume of 500 milliliters. What is the new molarity? M1 is 0.1 molar, V1 is 250 milliliters, M2 is M2, V2 is 500 mLs. M1V1 equals M2V2. Plug in the values, rearrange to solve, and you get 0.05 molarity being the new molarity. One for you to do, 175 milliliter solution of 0.150 molar sodium hydrogen carbonate is diluted to a new volume of 1.25 liters. What is the new molarity? Stop, work it out, come back, and see if you were correct. And the answer is 0.0210 molar. How did we get that? M1 is 0.150 molar. V1 is 175 milliliters. Notice it's 175 milliliters. The other volume is in liters. So I'm going to convert milliliters to liters, divide by 1,000. So I have 0.175 liters. M2 is equal to M2, and V2 is 1.25 liters. M1V1 equals M2V2. Plug the values in, rearrange, and you get that 0.0210 molarity. Third problem, how much water must be added to 150 milliliters of a 1.30 molar solution of sucrose to make the solution 0.845 molar? Stop, work the answer, come back and check. And you should get 81 milliliters. You may have come up with 231 milliliters, but that answer is incorrect. Let's run through it. M1 is 1.30 molar, V1 is 150 milliliters, M2 is 0.845 molar, and V2 is equal to V2. M1V1 equals M2V2, plug the values in, rearrange, and you get 231 milliliters, and you go, but that was the answer I got. So now we have 81 milliliters, which I say is the correct answer, versus 231 milliliters, which you may say is the correct answer. But look at what the question asks. The question asks how much water must be added to the 150 milliliters. The final volume is 231 milliliters, but the original amount of water was 150 milliliters. 231 milliliters minus 150 milliliters is 81 milliliters of water added, so that's where the 81 comes from. So to review, dilution is adding solvent to solution, which will decrease the ratio of solute to solvent. This will lower the molarity of the solution. Concentration is removing solvent from the solution, which will increase the ratio of solute to solvent, and this will increase the molarity of the solution. Since the number of moles will remain constant despite changing the amount of solute, then molarity and volume are inversely related. So you get M1V1 equals M2V2, which is the dilution equation. As long as V1 and V2 are in the same units, you don't have to do any volume conversions. If they're in different units, you got to convert one to the other's units. And that, in a nutshell, is dilution.